Okay, future engineers, welcome to our module 10 on curvilinear motion, rectangular components. So, last time we talked about curvilinear motion. So, curvilinear motions are motions along a curved path. So, in a projectile motion, which is also a curvilinear motion, it moves along a curved path. We only consider that x and y component of the projectile motion. In the curvilinear, katong isa katong circular, we consider the normal and tangential components. So, in our analysis before, we analyze a particle only in 2D. But starting from module 8 and 9, applying Newton's second law of motion, we already considered forces along the three-dimensional components, the x and y and the z. So now we are analyzing particles in 3D. So same with curvilinear motions also. So we will analyze the forces and then the acceleration and the velocity of the particle in the three components in the 3D way. So we have here in the rectangular components, we have the x-axis, the y-axis, and this z-axis, just like what we discussed earlier. Okay. So the motion of a particle can be described along a path that can be expressed in terms of x, y, z coordinate. Okay, so ang particle, di ba sa akong gi-mention earlier, may move at on that side, on that way. It moves in a curved path. Then we have an x distance or distance along x, like here. We call this x as a distance. So its distance from origin along the y-axis, we call that the y distance. And then from the origin to the z-axis, we call that the z distance. So if you remember, I discussed that magnitude of the acceleration for this one is just equal to the square of the acceleration x plus square of the acceleration y along y, and then the square of the acceleration along z. So kung lahi lang ang component sa acceleration, na po lahi ang component sa velocity. So velocity, magnitude of the velocity. So when we say magnitude of acceleration, magnitude of velocity, this is a scalar quantities. So we have vx squared plus vy squared plus vz squared. So xyz denotes the velocity along the xy or z. Now for this one, for the position, we have r. We use r. So from the origin to this particle, we use r. So that's why we have r here. For the magnitude of the r, we just use this one, x squared plus y squared plus z squared. Take note that x, y, and z here denotes distance, either in meters or in foot, it depends. So this is the scalar quantities, these are magnitude. But if we talk about the vector quantities, the vector of acceleration, diba? We use ax, acceleration along x, I hat, plus acceleration along y, j hat, plus acceleration along z, k hat. Same applies for the vector of the velocity. We have the velocity along x, I hat, plus the velocity along y, j hat, plus velocity along z, k hat. Same also with the position, r. We can say x, I hat, this is the distance along x, plus y, j hat, plus z, k hat. So sir, nano wa man siya nagamit og hat is just a simply ijk. Here, another way to show the vector unit vector in a problem is gibold na to sa letter. That's why r here is bold because this is a vector quantity. I, j, and k is called because these are unit vectors. Now, kung magsulat tayo nga, hindi mo na ito na-evolve, then we use the I hat. And then for the vector, actually, we have here, we have these symbols. It denotes that it has direction. So this is the vector, this is the scalar. This is magnitude of acceleration, velocity, and the position. This is the vector acceleration, vector velocity, and the vector position. Or the, yes. So maragay po na diri yung velocity, vector velocity is equal to Vx I hat plus Vy j hat, Vz k hat. So it's just that simple as I represent. Okay. So unsaon man ni siya? So natin nga nino. Okay, let's further discuss now. So di ba ang atong gigamit nga position null here is r. We know that the velocity is just the derivative of the position with respect to time. So since r atong gigamit diri dili si s, so we can say that the vector velocity is just equal to the derivative of the r with respect to time. And then acceleration is just equal to dv over dt, ana lang. Or the second derivative of r with respect to time. Sumala na siya. So here, since this is a vector, and then giderive na to si r, that's why we have three components also of derivation. Naapod si x, we have dx I hat over dt plus dy j hat over dt plus dz k hat over dt. It's just the same. Yan lang na siya. So atong gitagsa-tagsa, and we have here. So ang derivative ni position x I hat is equal to dx over dt times I hat plus x times di hat over dt. So this is a product of differentiation. So, and we know that the I hat or the direction does not change. So this is this is constant. So derivative of any constant is just 0. So this becomes 0. Then derivative of position along x is just this one. Same also with with y and also with z. Now let's look about this one. If you notice the velocity along x, we have x and a dot up here. This denotes a first derivative of x. Muna siyang x dot. Mura na siyang x prime. Di ba x prime in prime notation sa calculus, that is first derivative of y. Here di ba natay y dot. So this is last like y prime lang yun, derivative of y. This is z dot sa ibabaw. So we have it's just like z prime or the first derivative. So kani siya gigamit lang ni siya ni Newton to show us that the velocity along x is the first derivative along the distance. We can write this as dx over dt. This is dy over dt in Leibniz notation, and this is dz over dt in Leibniz notation. So let's move with acceleration. So acceleration again is just the derivative of the velocity, diba, with respect to time. And our acceleration has three components again, ax I hat. So this is vector acceleration plus ay j hat plus az k hat. Our acceleration along x is, kung inyo na-notice na lang po vx, then na dots ay babaw. So pasabot, this is the derivative of the acceleration is the derivative of the velocity. So mura na tang nagsulat of ax is equal to derivative of the velocity along x with respect to time. Mura na yan eh. Then yun na-notice nga duha ka dot pasabot second derivative siya ni position. So mo to akong giingon ninyo nga d squared x over dt squared. It just look like this. So ay na ninyo libog-liboga inyong kaugalingon para di na ta magproblema. So way lang ni siya ni Newton before to differentiate or to show us that the acceleration is the first mo nang isa diri derivative of velocity along y, or the second derivative mo nang duha kay second derivative man of y, of the position. And this is the magnitude of the acceleration as discussed earlier. So this is just the component of the rectangular components of the curvilinear motion.